that there have been satellites, launched into space since the 50s now at this point. But the change that's happening in the last couple of years has been a huge increase in the number of satellites being launched and the number of satellites that are planned to be launched. And everybody, including the satellite operators themselves, have been surprised to see how bright these satellites are. They can be illuminated well after sunset because the sun is still reflecting off of the satellite body or the solar panels of the satellite. And so they can be very bright to ground-based observers, even in the nighttime. So I primarily work for Rubin Observatory, which is this wonderful 6.5-meter telescope under construction in Chile. It's going to survey the whole night sky, like you were saying, in full color. It's going to help us find really deep, faint sources, really interesting moving variable sources. But all of the really cool ways that we're designing Rubin Observatory to be able to find these amazing new phenomena is also the exact same characteristics that make it really vulnerable to large numbers of bright low Earth orbit satellites. And that's simply because it has a really wide field of view. So you're more likely to get a satellite streak across any given image that you take. And it also has a large mirror, makes it very sensitive to things that are even relatively faint.
So in my area of astronomy, so I try to find Kuiper Belt objects in the distant solar system, right? So these are very, very faint. I'm using wide field imaging, so the Vera Rubin Observatory will be awesome for this kind of astronomy. And so I need to stare at a spot on the sky for a few minutes to gather enough light to see these really faint objects. And during that time, many satellites could fly through the field of view that are millions of times brighter than the very faint objects that I'm trying to find. So yeah, wide field astronomy will be the most strongly affected. There are different types of astronomy that will not be as strongly affected, but could have really big consequences if a satellite does fly through. So trying to find exoplanets right next to a star, you have a very small field of view, but your instrument is incredibly sensitive. So the odds of a satellite flying through are small, but if it does, it could really damage your instrument, right? Near Earth objects are most easily found close to twilight, which is when satellites are the brightest and are going to cause the most confusion, right? And finding near Earth objects is, I would argue, the most directly important part of astronomy, right? Like protecting our planet from something that could potentially kill everything on the planet, right? So this is not an area of astronomy we want to mess with. It's important.
And the problem with radio astronomers is it's not just a streak in your data. If you have a satellite signal in your data, it's basically blinding the whole telescope and you cannot just edit the data. So the problem is, of course, we have developed along with radio technology, and yes, a lot of the there are some bands protected, and we have learned to share part of the spectrum. But the protected spectrum is only about 1% of the frequencies that we really want to look at. And a satellite is 1 billion times stronger than a normal radio source we try to look at today, and not even speaking about the next generation of telescopes like the SKA. So we have tried to build the SKA, for instance, in radio protected zones where there is no emission, but it's only emission on the ground. And nothing protects you from satellites, they're everywhere. So, and it's just the sheer number of satellites that suddenly appears. In the past, we could organize our observations maybe to avoid some satellites, but that won't be possible anymore in the future. Now we have all these cheap satellites, and we're not only talking about OneWeb or SpaceX or whatever, but also these nanocubes. They're equally cheap, and they have much more danger than the current generation of satellites. So it's really the probability that one of these satellites goes rogue, so to speak, and is polluting the protected signal spectrum. Once it's up there, it's very difficult to fix, if not impossible to fix. Then we have to live with it, and it's impossible.
Well, the moon's an absolutely horrendous place to do things, and we're struggling at the moment to try and work out how we put humans back there. I mean, dust is a major problem and on the moon. It's really nasty kind of dust. It's not rounded pebbles like on a small scale dust is on the Earth. It's incredibly sharp, nasty stuff, and it cuts through electronics cables, gets in suits, it gets all over mirrors. But it's, vastly expensive, and this debate keeps coming up. Well, you know, the billionaires will just pay for you to build all the telescopes in space from the proceeds of their satellite constellation. And I think, that's not the world I live in, so I'm not really sure.
If we're being honest with the world, I think we shouldn't give the impression that it's, you know, destroying the sky right now. It's not that bad. It's already annoying for amateurs and professionals, but it's not that bad. It's a question of where the hell is this going to stop? No, we have no way to understand how bad it's going to get.